We still have the limit when x approaches infinity, positive or negative. And we have rational function. If we substitute for infinity, the final result will be infinity over infinity, then it's not number. So the method to find the limit when x approaches infinity is to divide by the term that has maximum exponent. The maximum exponents, here is students confuse. They say, oh, it's x squared, and then they divide x by x squared, and here is a divide by x squared. No, look at this, we have radical here. We have radical. So the maximum exponent will be x at the top, and the maximum exponent will be square root of x squared in the bottom. So what you could do here, you divide the top by x, and here is minus 3 over x, divide by the bottom, it's radical. So square root of 4x squared will be divided by x squared. Yes, because radical of x squared is still x, plus 25 divided by x squared under the same limit, x approaches infinity. And now you see that x divided by x is 1, minus 3 over, when you see x, just plug it in infinity, it's over infinity here. Divide by square root of x squared, cancel x squared, then 4 left, plus 25. When you see x squared, the same as infinity square, and infinity square, infinity to the fifth, infinity to the 6th power, infinity to the 7th power, still infinity. And as we learned before, any number divided by infinity except infinity, any number divided by infinity will be 0. So it's 1 minus 0 divided by square root of 4 is 2. And 25 divided by infinity is 0. So the final result will be 1 minus 0 over 2, which is 1/2. Here is, we have the limit when x over x, 4x squared plus 25. It's the same, but this rational function doesn't include radical in the bottom. So what you could do here is to divide all terms by the maximum exponent, x squared. So x will be divided by x squared minus 3 divided by x squared, and 4x squared will be 4x squared divided by x squared, 25 over x squared, under the same limit when x approaches infinity. Now x over x squared is still 1 over x if you simplify, minus 3 over x squared, over, cancel x squared with x squared, 4 left, plus 25 over x squared. Now we could start to plug it in infinity. So this will be 1 over infinity. 1 over infinity is 0. Minus 3 over infinity square, still 0. Over 4 plus 25 over infinity square is still infinity. 25 divided by infinity is 0. The final result will be 0 over 4, which is 0. In general, when you see the maximum exponent will be in denominator, in the bottom, then the final result will be 0. Okay? Add it to your experience. When you see the maximum exponent in the bottom, then it will be 0. In the top, it will be infinity. Now we come to another example here. Find the limit of 4 minus x to the third, this is to the third, divided by x to the 6th plus 9 when x approaches infinity. All of you will say, okay, we will divide by the maximum exponent and it's the x to the 6th. Don't. You know, big difference between numerator and denominator. Denominator include radical. And radical of x to the 6th is the same as x to the third. So what you could do here is to divide 4 by x to the third and x to the third by x to the third. When you come to denominator, the situation will be different. X to the 6th, you divide it by what? By x to the 6th. Because radical of x to the 6th is still x to the third. plus 9 divided by x to the 6. And now when we plug it in the infinity, you see, when we plug it in infinity, that will be 4 over infinity, 4 over infinity, minus x to the third over x to the third is 1, divided by x to the 6 divided by x to the 6 is 1, so it's radical 1, plus 9 divided by x squared is the same as 9 over infinity, and it would be 0. This will be 0, and this will be 0. So it will be negative 0 minus 1 is negative 1 over square root of 1 plus 0, and it will be 1. The final result will be negative 1.